Okay, good morning to everybody. Today we'll start the chapter limit and continuity. First of all, what is limit of a function? We must know about the in our previous lecture what is function and different types of function. So today we will start with the limit of a function. A function, a function f of x is said to have a limit L as x tends to a. If the difference between f of x and L is less than any given positive number however small mathematically mathematically limit x tends to a, then f of x equals to L. L must be a real number. You must remember that L must be a real number. Now another definition is that start previous lecture. Epsilon del definition. Epsilon del definition of limit. Okay, epsilon del definition. From our book, we must know about the epsilon del definition. Let f is a function from real number to real number. That means domain of real number and range also real be a function. Then f of x is said to have limit L if there exists epsilon greater than 0 such that minus L less than epsilon, satisfying satisfying x less than L, where epsilon and del are very small. That is del greater than 0 and epsilon also greater than 0. Then we get, we can write limit x tends to a f of x equals to L. That means if x tends to a, then f of x will be equal to L. That means f of x will tends to L. If x is very near to a, then f of x will be very near to L. And L must be a real. So the functional difference will be very negligible, less than epsilon, where epsilon is very small, which is greater than 0. That means positive number. Then we and satisfying the distance point difference. This is the functional difference, and this is the point difference. So there are two neighborhood. One is suppose this is the neighborhood. This is the center, and del is the radius. Okay. So there are many points below x. Okay. So their distance will be less than del. So another neighborhood. This is the del neighborhood. Another neighborhood. Suppose this is the epsilon, and this is the epsilon neighborhood. Okay. So this epsilon neighborhood, there are many f of x. So this is the actual input, and this is the output. So if we get the functional difference f of x minus L very negligible, that means a small, however small positive number, then we can say that f of x will be equals to L. Okay. So this is the actually epsilon L definition or limit. You can use any definition. So there are two types of limit. One is left hand limit, other is what? Right hand limit. So left hand limit and right hand limit. Left hand limit can be given a limit x tends to a. This minus only for left hand limit of x equals to, this is actually H rule, H method. Limit h tends to 0. If we convert it to x tends to 0, that means x equals to what? X equals to what? A minus h. Okay. Here x equals to a minus h. If we put x equals to a minus h here, it we get h tends to 0. Okay. And for the right hand limit x tends to a plus. This plus is for only for right hand limit, to denote the right hand limit. Because suppose this is the a, and this is a plus h, and this is the a minus h. Okay. So to get the left hand limit, this will be the a minus h, x equals to, and for the right hand limit will be what? A plus a. Then we get the limit at x tends to a. So if left hand limit equals to right hand limit, then limit exists. Then limit exists, or the function has, or the function has limit at x equals to a. That means at x equals to a, the function has limit. If these two limit, that is left hand limit and right hand limit, is equal, then you can say that the function has limit. Otherwise, not. Remember it. Okay. Now, what will be the continuity of a function? Okay. What is the continuity of a function? What is continuity of a function? So, the simple definition for continuity of a function. a function f of x is said to be continuous. To be continuous at a point x equals to a if limit of a function if limit of a function f of x at the point exists, limit exists. That means first condition what? Limit of function exists. That means it must have a limit and is equal to the value of the function at x equals to a. This is the simple definition of limit. Sorry, continuity. That means we can say that. So what will be the continuity of function? First condition what? Limit exists. Okay. First of all, f of a is defined. That means at x equals to a, we get a value. Second condition is limit x tends to a f of x equals to f of t. If these two conditions is satisfied, then we can say that it has a continuous, the function is continuous at x equals to f. F of a is defined and limit exists. We can say this is limit exists. Limit exists. Then another condition we can add, limit x tends to a f of x equals to what will be f of x. The functional value will be equal to the limit values, both that limit and that limit. In that case, then we can say that this is the continuous. The function is continuous at x equals to a. Okay, now one example of limits for piecewise function. Actually, this is a piecewise function. P I E C wise function. Okay. In previous lecture, we have solved for what? Polynomial function. So today this is piecewise because one function is defined for, suppose this is the x equals to 2 and x equals to less than 2 is this. Okay. Less than 2. And here x greater than 2. Okay. So this is the left hand limit and this will be the for right hand limit. So let us we can find the left hand limit. Suppose left hand limit x tends to 2 f of x. So by A's method, limit A tends to 0. Okay, f of a minus 2 minus is, this will be what? 2 minus is. So this f of x value what? F of x value limit A tends to if we take the direct one, limit x tends to 2. What's the in which function x less than 2? In which function? X less than 2, minus x plus 3, okay? Minus x plus 3. So if we convert it to a's, then we get a minus a. That means 2 minus a's. 2 minus a's plus 3. So putting a equals to 0, we get what? Minus 2 plus 3 equals to what? 1. Then another one, right hand limit, what will be? Right hand limit. Similarly, x tends to 2 plus for right hand limit. So for right hand limit, in which function x is greater than 2? In which function x greater than 2? X minus 1. Okay? X minus 1. So converting it into a's,
সাবির একটু
we
মিউট কর
get
না বাবা।
2 minus 2 plus a's. Okay? Minus 1. So 2 plus 0 minus 1. That means 1. Since left hand limit equals to right hand limit, therefore limit exists. The function limit exists at what? At x equals to 2. Remember it. Limit exists at x equals to 2. Now we can plot this function. Now suppose I have a graph like this. This is the 0, and this is the x axis, and this is the y axis. So 1, 2, 3, 1, 2, 3. Suppose this one, 1, 2, 3, and this is another 1, 2, 3, 1, 2, 3. So we can plot this function. Suppose this is, we can get this curve, and actually we are examining the limit here, f of x. Okay, this is the limit. So for this left hand limit, and this is the right hand limit. This is the left hand. This is the sign for left hand limit, and this is the sign for right hand. So 1, 2. X tends to 2. Then we get a limit here. The limit equals to what? 1. Limit value what? 1. Actually, this is the value 1. So this is the graph for this function. Because this is the x equals to this means what? You can plot this one. This is the second function, and this is the what? First function. Remember it. Exponential. So we got the values here. Limit, left hand limit and right hand limit equals to 1. So okay, another example for continuous. Example 2. If f of x equals to twice x minus 5, if x not equal to 1, and f of x equals to 3, if x equals to 1, then examine the continuity of the function. Continuity of the function. So for the solution, first of all, this is actually a piecewise function. You must know what is a piecewise function. So we have to examine the continuity at what? Continuity at x equals to 1. Continuity at x equals to 1. So for this, first of all, we have to find out the functional value of the given function at x equals to 1. So x at x equals to 1, what's the functional value actually? This is the 3. Okay, 3. Okay, from the given function, we observe that at x equals to 1, f of x equals to what? 3. This is why f of 1 equals to 3. Now, left hand limit. Left hand limit, how we can find? You must know from the definition, x tends to 1, f of x. So, x less than 1 in which function? X less than 1 in which function? You must know left hand limit x less than 1 or greater than 1 actually from the above function. So we get the original value of limit. So this is the what? Y6 minus 5. If we convert it into a stands to 0. A stands to 0 what? 2 into a minus a or a plus 6. So 1 minus a minus 5. So if we put a is equals to 0, then we get. So what will be the value? Minus 3, right? Similarly, right hand limit. Right hand limit. What will be? Limit x test 1 plus f. Actually, in which function? 1 plus in which function? X greater than 1. Actually, this, of course, this will be y6 minus 5 because it's not equal to y6 minus 5. So, in that case, applying A's method, A tends to 0 plus 1 plus A's. Okay. Similarly, putting A is equals to 0, we get also minus. Okay. From this line, since left hand limit equals to right hand limit not equals to what? F of 1. Okay. Because this left hand limit and right hand limit equal. But f of 1 equals to what? 3. So this is why not equal to 1. So the function is not continuous at x equals to 1. So we can plot the graph for this. We can plot the graph. Suppose this is the x-axis and this is the y-axis and with the origin. So suppose 1, 2, 3, 4 and 1, 2, 3, 4, 5. Suppose this is the 1 and 1, 2, 3. So f at x equals to 1, suppose x equals to 1. So f of x equals to what? 3. This is the actually value. We can plot it in red one. Suppose this is the f of x. Okay. And another function y6 minus 5. So this is the 1, 2, 3, 4. This is the graph of y6 minus. For every input of x, we get the value of f. So this will be the function. Okay. And this value what? Intersection point 5 by 2. x equals to 5 by 2. Okay? If y equals to 0, then we get these values. These values what? 5 by 2. This value 5 by 2. And this is the point 5 by 2 comma 0. So we got the limit here actually. Yeah, we get the limit. This is the minus 2, minus 3, minus 4, minus 5. So we got limit here. Okay. And we obviously see that this is actually at x equals to 1, we get f of x equals to 3, but limit we got at what value minus. So this is the discontinuous. From the figure, we see that the function is not continuous. Okay, from the figure, this is what the function is not continuous. Okay, now another example. Example 3. Examine the continuity of f of x equal to x square plus 1 if x less than 1, and f of x equals to twice x if x equals to 1, and f of x equals to minus x plus 3 if x greater than 1 at x equals to 1. That we have to find out the continuity of this function at x equals to 1. So we have to examine this. So first of all, for the solution of this, f of x equals to given this. Okay, given f of x equals to what? X square plus 1 if x less than 1, and twice x if x equals to 1, and minus x plus 3 if x greater. So from here, f of 1 equals to what? We have to find out continuity at x equals to 1. So f of 1 equals to what? In which function? In which function we have x equals to 1? Okay, this third function at x equals to 1. Okay, second one. In this part, this is the piecewise function. So x equals to 1 in which function? F of x. Twice x. So 2 into 1 equals to what will be? 2. Now left hand limit. Left hand limit. Limit x tends to 1 f of x. X less than 1 in which function? X less than 1 in which function? In the first part of the function. X square plus 1. Limit h tends to h will convert, x will be converted into what? 1 minus h. That means I minus 6 plus 1. Now putting h equals to 0 here, we get what? 1 plus 1 equals to 2. Now right hand limit what will be? Right hand limit f of x in which part of this function x greater than 1? In which part? Minus x plus 3. Okay, because we are finding limit at x equals to 1. So this part will be x less than 1, and this part will be x greater than 1. So to find out this limit, this is the left hand limit and this is the right hand limit. Okay, this is the. So for this, using ACE method, A stands to 0. A stands to 0. X will be become 1 plus A. Okay. Now putting the value of ACE. This equals to what? Minus 1 plus 3. This equals to also 2. Since after this line, since left hand limit equals to right hand limit equals to what? F of 1. That means three values are equal. So the function is continuous at x equals to what? 1. Okay, now we can plot the graph for this. This is how this is continuous. We can plot this. Suppose 1, 2, 3, 1, 2, 3. This is the origin, and this is the x-axis. This is the y-axis. Actually, f of 1 equals to at x equals to 1. We get there are two limits at x equals to 1. At x equals to 1, we got 2, and left hand limit. This is the left hand limit. This is the right hand limit, and this is the functional limit. Okay, this is the functional limit. Another one is this. This is the x square plus 1 function, and this is the what in which function? Minus x plus 3 function. Okay, if x equals to 0, we have x equals to what? If x equals if y equals to 0, x equals to 3. This is why this is the third function, third part of the function. This is the first part of the function. This is the graph of what? First part. So limit exists in which point? This one at 1 and in at this. So the left hand limit we got 2, and right hand limit we got also 2. And f of 1 equals to what? F equals to 1. We get originally. So this is the right hand limit, and the functional value what? X equals to 2. And limits between this. Limit will be between this one, because limit between left hand limit and right hand limit will be at x equals to 1. So from the figure, we observe that this is actually f of x equals to what? F of x equals to x square plus 1. And this function will be what? F of x equals to minus x plus 3. So this is the function. This is the minus 2x, y equals to minus 2x. Okay, y equals to, so at x equals at y equals to 2, x equals to what? At x equals to 2, at of x equals to 2, also 2. So we get the limit here. One limit is here, and another limit is here. Okay, left hand limit, right hand limit. So and the functional value is 2. So from the figure we observe that the given function is continuous at x equals to 1. Okay, now another one. Example 3. Prove that the function x square minus 9 x minus 3 is discontinuous at x equals to 3. So we are given f of x equals to what? X square minus 9 divided by x minus 3. So f of 3 equals to what will be? First of all, we have to find out the value of functional value of at x equals to 3. So just putting x equals to 3 here, we get 0 divided by 0, which is undefined. Remember. Now left hand limit, what will be? Left hand limit x tends to 3 f of x. Left hand limit minus what? So limit x tends to minus 3. In which function x less than 3? Actually, the given function is same function. So because there are no specific domain, so from this line we can write x square minus 9 equals to what? X plus 3, x minus 3. Okay, divided by x minus 3. Limit x tends to 3. So this equals to what? X plus x minus 3 will be cancelled. Only x plus 3. Now limit h tends to 0, 3 minus h plus 3. Putting h equals to 0, we get 6 equals to 6. Similarly, the right hand limit, what will be? Right hand limit x tends to 3 plus 3 f x equals to, in which function? X greater than 3. Actually, the same function, x square minus 9 divided by x minus 3. Similarly, we get 3 f of x plus 3. Because x square minus b square formula, then x minus 3 will be answer. So, A's method, applying A's method, 0, x converted to what? A plus x. That means 3 plus x. Okay, now putting the limit values, we get equally 6. That means what? Left hand limit equals to right hand limit, but does not equals to what? F of 3, because f of 3 is undefined. So the given function is discontinuous. Discontinuous at x equals to 3. Discontinuous at x equals to 3. So another example of continuous. A function f of x is defined as f of x equals to half minus x when x lies between 0 and half. That means 0 less than x less than half. And f of x equals to 0 when x equals to half. And third one, f of x equals to 3 by 2 minus thrice x when half less than x less than. Then show that f of x is continuous at x equals to half. So how we can solve this function? How we can solve? Suppose we have to find out the continuity at x equals to half. Therefore, solution will be like this. F of half equals to what will be? At x equals to half. In which function? At x equals to half, f of x equals to what? 0. From the given function, we observe that at x equals to half, f of x equals to what? 0. Now left hand limit. Left hand limit. Limit x tends to half. That means x tends to a. A equals to what will be? Half f of x. Limit x tends to half. In which function? X less than half. Which part of this function? This is the piecewise function. So x less than half in which function? Which part? First part. Okay. X less than half. X less than half in which f of x? Half minus x. Now by using A's method, x will become a minus h. That means half minus h. Putting h equals to 0. So we get 0. Now right hand limit x tends to half plus f of x. Limit x tends to, in which part of this function? X greater than half. X greater than half is the third part. 3 by 2 minus thrice. this equals to 3 by 2. So by using A's method, this equals to limit A tends to 0. Half A plus A. That means half plus A's. A's will be converted to A plus A. That means half plus A because A equals to half A. So just put in A is equals to 0. We get 3 by 2, 3 by 2. That means 0. Since left hand limit equals to what? Right hand limit equals to what? F of half. That means three values are same. So the function is continuous at x equals to half. Very easy math. Okay, now another example. Example 5. A function f of x is defined as f of x equals to, there are three values. This is also piecewise function. A piece. There are three pieces of this function. So this is why it is called piecewise function. So for this one, 3 plus twice x for minus half less than x less than 0. And second piece, 3 minus twice x for x 0 less than x less than minus less than half. And third one, minus 3 minus twice x for x greater equal to 3 by 2. So that f of x is continuous at x equals to 3 and discontinuous at x equals to 3 by 2. Remember, this is the value. Okay. So that f of x is continuous at x equals to 0 and discontinuous at x equals to 3 by 2. So first of all, for x equals to 0, for x equals to 0, first part, at x equals to at x equals to 0, okay, at x equals to 0, at x equals to 0, f of x equals to what? At x equals to 0, f of 0 equals to what will be? Actually, the functional value is actually there is a mistake, minus 3 by 2. This will be minus 3 by 2 and this will be less equal to sorry, less equal to x. 0 less than and this will be 3 by 2. This also less equal to and x greater than 3 by 2. So at this, for x equals to 0, f of 0 equals to what? 0 less equal to x. That means x equals to 0 lies in this part of the function. So 3 minus 2 into 0. Okay, this equals to 3. Now left hand limit. We have to find out at 3 by 2. At 3 by 2. Okay, sorry, at 0. So left hand limit part will be in which function x less than 0. In which function x less than 0. X less than 0 is the first function. 3 first part of the function 3 plus twice x because x less than 0 lies in this part. First part. Now using the A's definition, 2 into a minus x. Okay, a means 0 minus x. Now putting A's values, this equals to 3. Similarly, right hand limit what would be? X greater than 0 lies in which part of this function? X greater than 0. X greater than 0 is the second part. 0 less equal to x. That means what? X greater equal to 0. That means 3 minus twice. So 3 minus twice. Now using the A's definition, 3 minus 2 a plus a. A means what? 0 plus A's. This equals to 3 minus 2, 0 plus 0. That means 3. Actually, we got every value same. Left hand limit equals to right hand limit equals to f of 0. That means so the function is continuous at x equals to 0. This is actually first part. Now another second part. Second part for what? X equals to 3 by 2. Second part for x equals to what will be? 3 by 2. The functional value will be what? At x equals to 3 by 2 in which piece of this function? Minus 3 by 2 less equal to okay. Third one. At third piece of this function, third part of this function has x equals to 3 by 2. So minus 3 minus 2 into 3 by 2. 2 will be cancelled. Minus 3 minus 3 what will be? 6. Okay. Now left hand limit what will be? Left hand limit will be what? X less than 3 by 2 part of this function. X less than 3 by 2. That means in the middle of this part. That means 3 minus twice x. That means second part of this function. So if we convert it into a's, then what will be? A minus a. Okay. That means 3 by 2 minus a's. Minus 0. That means 2 will be cancelled. So this will be 0. Now right hand limit what will be? At x equals to 3 by 2. X greater than 3 by 2 in which domain? X greater than 3 by 2. That means in the third one. In the minus twice. The third part of this function. Now using the x method, this limit a tends to 0. X become what? A plus h. That means 3 by 2 plus h. Now putting a's value. So the 2 will be cancelled. So minus 3 what will be? Minus 6. Left hand limit does not equals to what? Right hand limit. And does not equals to what? 3 by 2. Sorry. This will be equal. So the function is not continuous. Okay. At x equals to 3 by 2. This is the second part of this. Very easy. Okay, now the last example, example 6. A function f of x is defined in the interval 0, 3. This is the open interval. That means x lies between these 3. Okay, excluding 0 and 2. So the f of x is equals to what? But this is also piecewise function. F of x equals to x square when 0 less than x less than 1. And f of x equals to x when 1 less equal to x less than 2. And f of x equals to 1 by 4 x cube when 2 less equal to x less than 3. Then show that f of x is continuous at x equals to 2 and x equals to 1. So for the first part, our first part will be for what? X equals to 2. For x equals to 2, f of 2 equals to what will be from this given function? F of 2, x equals to 2 lies in the third part of this function. That means 1 by 4, 2 cube. Just putting x equals to 2 in this part. So we get 8 by 4. That means what? 2. Now left hand limit 2 in which function x less than 2. X less than 2 in which function? In the second part of this function. Only x. Okay? Only in this part, x less than 2. So limit a tends to 0 using ace method. A plus a. That means 2. Sorry, a minus 6. 2 minus 6. Okay, x equals to 2 minus 6. So thus 2 minus 0 equals to 2. Now similarly, right hand limit x greater than 2 in which function? X greater than 2. This one, last one. Okay, 2 less equal to x. That means x greater than 2. So 1 by 4 x cube. Okay. Now using x method, limit a tends to 0, x become what? A plus ace. That means 2 plus ace. Now putting h equals to 0 here. This equals to 1 by 4 into 8. That means 2. That means every value is 2. Okay. So left hand limit equals to what? Right hand limit equals to f of 2. That means the function is continuous at x equals to what? 2. This is the first part. Okay, now second part of this, that means for x equals to 1. Second part, for x equals to 1, the functional value what would be for x equals to 1? That means 1 less equal to x. That means here. So f of x equals to x. That means x equals to 1. So we get f1 equals to 1. Now left hand limit at x equals to 1. What will be? X less than 1 in which function? Which part of this function? First part. Because x less than 1. Okay. So now using age definition, a minus a. That means what? 1 minus a whole square. So putting the value of a, we get equals to what? 1. Now similarly, right hand limit what will be? At x equals to 1. X greater than 1 in which piece of this function? In which pieces? X greater than 1. That means it's first part. So this one, f of x equals to x, because 1 less equal to x. So x greater than 1. Now using age definition, 0 a plus a's. That means 0 sorry 1 plus x. So the value will be just putting a equals to 0. That means left hand limit equals to right hand limit equals to what? Functional value. Therefore the function is continuous at what? X equals to 1. Very easy. This one, examine the continuity of this function. This means this one. This is also piecewise function. F of x equal to x cube minus 8 x square minus 4 if x doesn't equals to 2 and x doesn't equals to minus 2. Another function f of x equals to what? 3. So if x equals to 2. Okay.
So at the point x equals to 2 and x equals to minus 2, we have to examine the continuity. Okay, at x equals to f of 2 equals to what? 3, and left hand limit, right hand limit. Okay, if these 3 are equal, then we get continuous, and if these 3 are not equal, then it will be discontinuous. Okay, this will be homework for you. And another one, this is very important for you. F of x equals to twice x plus 4, x minus 5 if x equals to 3, and bx plus a if x is less than 2 is a function which is continuous at x equals to 3. That means you are given a continuous function. Find the value of a and b. Since f is a continuous at x equals to 3, we know that limit will be f of 3 na? By the definition of limit x tends to 3, f of x equals to what will be? F of 3. We also write right hand limit what? Equals to this. So right hand limit we get from this graph equals to twice a into 3 plus 4. That means a equals to minus 1. Similarly, for the left hand limit, just putting the values of left hand limit, okay, we get the values of this. Okay, now another example. Example 7. A function f of x is defined by f of x equals to twice x plus 4 if x greater than 3, x minus 5 if x equal to 3, and bx plus a if x less than 3. And is a function which is continuous at x equals to 3. Right? So we have to find out their constant value a and b from here. So to find the constant values, here we have to use the definition of continuity solution. Since the function is continuous at x equals to 3. So we can write limit x tends to 3, f of x equals to f of 3. Okay? By the
স্যার
definition of
ফাইনাল ভ্যালুস অফ কি লিখছেন বোঝা যাচ্ছে না।
now left hand limit equals to what? Now left hand limit also 3. Left hand limit equals to what will be also 3, or limit x tends to equals to will be also x less than 3 in which function? X less than 3 in which function? X less than 3 in which function? Bx plus a, okay? X less than 3 in which function? Do you know? This one. B into 3 plus a equals to f of 3. This is equation number 1. Now for the right hand limit, again, right hand limit equals to also what? F of 3, or limit x tends to 3 plus f of x equals to f of 3, or limit, sorry, 3 greater x greater than 3 in which function? Twice x plus 4. Okay, twice x equals to 3 plus 4. F of 3, x equals to 3, f of 3 equals to what? You must know f of 3 equals to what will be? At x equals to 3, x minus 5. That means 3 minus 5 equals to what will be? Minus 2. So this is equals to minus 2. Or 6a equals to what? Minus 3. Therefore, a equals to what will be? Minus 1. Now from equation 1, 3b plus a equals to what? F of 3.
or 3b plus a equals to -1 and f of 3 equals to what? -2. Therefore, 3b equals to -2 plus 1. Therefore, b equals to what? B equals to -1 by 3. Hence, a equals to -1 and b equals to what? -1 by 3. This is the result. By using the definition. Okay, since the function is continuous at x equals to 3, so by using definition of continuity, limit x tends to 3, f of x equals to what will be f of 3. But f of 3 at x equals to 3 what? 3 minus 5, that means -2. So just left hand limit equals to f of 3, left hand limit, but left hand limit x less than 3. In which function? X less than 3, bx plus c. Okay, bx x equals to 3. Okay, just putting the limit values. To get this equation number 1. Similarly, right hand limit equals to what? F of 3. But right hand limit, according to the equation, limit x tends to 3 plus 3 f of x. But right for x greater than 3, f of x equals to what? Twice x plus 4. But x equals to what? 3. So 6x equals to -6. Equals to what? -2. Because f of 3 equals to -2. And now from equation 1, just putting the value of x here, we get and f of x and f of 3 also. So f of 3 equals to -2. So -1, -2, what will be? -2 plus 2 in the right hand side. So b equals to what? -1. So this is the required result.
স্যার এটা কি এখানে শেষ? আমাদের স্যার 45 থেকে স্যার ক্লাস আরেকটা আছে, আবার এরপর আরো একটা আছে, টোটাল 2টা।
Okay, okay. So we have actually today we have learned about limit and continuity. Actually, the diagram I have not used here. You can interested. This is the diagram of the limit of function. I have defined this. Okay. First of all, it's not is the del values within the uh, del neighborhood, and for external neighborhood will be y value. So this is the diagram for limit of the function. And this is the left formula for one side limit and the left limit, and right hand formula. Okay. Now this is the loss of limits. I have used if you are at the two function, then the limits will be individual. And this is the addition of subtraction. Okay. This is the constant multiplication. And this is the product of loss of limits. Product loss of limit. And this is the quotient loss of limit. If we divide two functions, then we can get the individual values of the limit, provided by the denominator will be not equal to 0. So thanks to everybody. Best for you. So bye.
Sir. Hello, sir. Assalamualaikum.